everyone would have played chess game, right? So how does a chessboard looks like?
Square.
A square matrix. It looks like a square matrix. Either it is 8 cross 8 or 4 cross 4. So the same chessboard problem we are going to discuss now. So we are going to discuss about NP's problem. So what is the NP's problem is that you will be given a set of queens and you need to place the queen on the chessboard. So we are going to explore the possible ways in which the queens can be placed on the chessboard. However, we have some constraints, like we have explicit constraint as well as we have implicit constraint. So let us discuss what are the constraints and how the queen can be placed on the chessboard.
Let's see about the NP now. Which is the famous data structure algorithm. The objective of NP algorithm is to place a n in n cross n chessboard. Then queens attack horizontally, diagonally, and vertically. In chessboard, we must ensure that two same row we
No two queens can be placed.
no two column we can place, no two diagonal we can place.
So the constraints, there are 3 constraints in n queen. So first one is no queen should be placed in the same row. Second one is no queen should be placed in the same column. Then it should not attack diagonally. So when I place a queen in the first, so it should not be placed here, here. So in same, it should not place diagonally. So for each queen, we need to check all these constraints. Only if these all passes, we are proceeding to next. So if I place one queen here, and for row 1 and column 1, row 2, column 2, so their difference should not come as 1. If it comes, it is not the correct place to place the queen. So this is the 3 constraint that it should not place in the same row, same column, and horizontal diagonally.
So next we talk about the most important technique that we use in this NP, which is nothing but backtracking. So if you see, first we place the queen in first row. If you place the queen, then we will move to the next column. If it's a safe position, we will place it. Otherwise, if it is not a safe position, we will change the before row queen, and then we will replace the before queen, and then we will continuously iterate. In first step, what we will do, first we place the queen in first row. Then we will check which is the safe position we will place it. Again, next we will check it. If it is no safe position occurs, we will move to the before column, before row, and we will change that queen place, and then we will continue to iterate it. This is what backtracking will do.
Next, we are going to see advantage. So just like Nisha said, backtracking, instead of starting from the beginning, we just move to the previous question and we do the same, right? So of course it saves the time. And then efficient. Backtracking is an efficient method. So of course it's an efficient method to solve. And then logical thinking. We might choose, we might think which point to place so that no two points attack each other. So it will improve the logical thinking. And then its application. First, it's used in puzzle games like Sudoku, and then it's used in robotics, like which part we should choose correctly. So it's used in
So 4 cross 4 is also, and we have like 8 cross 8 also. It has thousands of possible ways to play.
So we were discussing about various constraints, right? So these constraints can be classified into 2 types. One is explicit constraint and another one is implicit. So what we have said, like no two queen can be placed on same row or it cannot be placed in same column and diagonally also. So it is explicit constraint because it is basically you can see it visibly, right? So and as Keerthana has mentioned, she mentioned another constraint like the difference between the row number and column number. If it is equal to 1, you cannot place the queen. So that is the implicit constraint. So why backtracking is used here is when you do not have any further solution to explore, you will move back to the previous step. That is your backtrack. You are exploring the path that you have chosen earlier. So in the path that you have chosen, you are going back to the same path. So that is why this technique is called as backtracking, and it is most efficient for solving NP's problem. So based on the n value, even if it is 4, 8 or 16, you can solve this. However, it is an n cross n, that is a square matrix. Only if the matrix is